Okay, compound locus is a special section that we do in 4-level. It's a continuation of the last section that we did with the work that we were doing with Locus. And I'm going to show you the type of problems that we're going to do here. Definitely a procedure that I recommend you following when you're doing these type of problems. So, first thing you want to do is you want to find each locus separately. So there's going to be 2. You want to do each separately. And then you're going to take those 2 locus and you're going to find all the possible ways that you can intersect the 2 locus. Loci? Question mark? Okay. Alright, so here's the first example. Find the locus of points that are a fixed distance from a given line. That's the first locus. And there's the key to recognizing it's a compound locus. Lie on a given circle. That's the second locus. So find each locus individually, fixed distance from a given line. Given line is going to be like this. The locus will be a fixed distance from that. Will just be the 2 blue parallel lines would be your locus for that one. And then lie on a given circle. So you're just telling you that it's a circle. And then you want to find out all the different ways that those 2 things can intersect. 2 parallel lines and a circle. So you can have zero points of intersection. You can have 1 point of intersection. You can have 2 points of intersection, right? You can have 3. Can you have 4? Yeah, absolutely, right? Here, if I draw the circle first, 4 points of intersection. Can I do 5? I cannot do 5. So those are all the possible intersections of the locus, and you are done with the compound locus. Pretty simple, right? Okay, so let's take a look at another example here. Find the locus in space. So, we're looking at 3-dimensional figures now, 3D, of points that are a fixed distance from a given plane. Okay, so a plane is represented by like a piece of paper, a flat surface, and there's the locus, a given distance from a fixed point on the plane. So a given distance from a fixed point. So a fixed distance from a given plane. So if I'm given a plane, a fixed distance would just be, well, there's going to be a plane up here, and then there's going to be a plane down here, the same distance away from that single red plane there. So the 2 planes are going to be 2 parallel planes to each other. And if we're talking about a given distance from a fixed point on a plane, so if I have a point on a plane, and it's a given distance from a fixed point, well, in 2 dimensions, that given distance would be a circle. In 3 dimensions, it's going to be a sphere. Cool, right? Very badly drawn sphere. So now what I need to do is take this sphere and intersect it with 2 parallel planes, knowing that one of the points, this one point right here, is in the original plane, so it's right there. Okay, so this point and that point are in the same place. So, but I don't know how big this sphere can get, so I can make it, get really big, or I can make it really small. So let's see, in step 2, I would be looking at two parallel planes with a sphere inside, like this. So that's the zero intersection. And hopefully you can see that there's going to be a case where you have where it's just going to touch right here and here. Okay, and you're going to end up with 2 points of intersection. And then the tricky one, basically when you have a sphere that's really big, and you have to think about how is it going to pop through that sphere. Well, it's going to jump through something like this. Okay, and the points of intersection would just be these two circles here and here. Okay, so I'm looking at two circles. And that's it. That's what you need to do for a compound locus. On the back side is just a bunch of example problems for you to try. So go ahead and give it a shot.